In this problem, they're telling us to solve the system of linear equations with three variables by any method. So the two methods that we know is the method of elimination, or what they call it addition also, or the method of substitution. In this example, I'm going to solve this problem using the elimination method. So for the elimination method, we're going to take two equations first, two equations at a time to eliminate one of the variables, and then but we have to be consistent with the variable that we eliminated. So if we choose the x variable, we have to be consistent by eliminating that variable. So let's call this one equation 1, equation 2, and equation 3. So first I'm going to take the first equation and the second equation. So 2x minus 2y plus 7z is equal to negative 33. Second equation is 2x plus 3y plus 4z is equal to negative 38. So now to eliminate the x variables, we need to have them the same value but different signs so they can be cancelled. So the x's have the same value. I can just change the sign on one of them, so I need to multiply the whole equation by negative 1. So I have now negative 2x, negative 3y, negative 4z is equal to positive 38. And I'm going to add the first and second equation. So 2x minus 2x, that goes to 0. These two cancelled. Negative 2y minus 3y, that's going to give us negative 5y, plus 7z minus 4z, that's going to be plus 3z, is equal to negative 33 plus 38 is going to give us 5. Let's call that equation 4. Now for the second one, we can take any two combinations, but they cannot be the same. So we cannot take the first and second equation again, but we can take, for example, the first and the third, or the second and the third. So here I'm going to take the second equation and the third equation. So 2x plus 3y plus 4z is equal to negative 38. The third equation is 7x minus 9y plus 9z is equal to negative 30. So the same concept, I gotta have the x's the same value but different signs. So for example, maybe I can multiply the top equation by negative 7 and the bottom equation by 2. So negative 7 times 2 is going to give us negative 14x. Negative 7 times 3 is going to give us negative 21y. And then negative 7 times 4 is going to give us negative 28z is equal. And then negative 7 times negative 38, let me double check that. It's going to give us 266. 266. Now for the third equation, is going to be 2 times 7, 14x. 2 times negative 9, it's going to give us negative 18y. And then 2 times 9, it's going to be positive 18z is equal. And then 2 times negative 30 is going to be negative 60. And we're going to add these two equations. X is eliminated. Negative 21 minus 18, it's going to give us 39y, 9y, and then negative 18z plus 18 is going to be negative 10z, and then 266 minus 60 is going to be 206, and let's call this equation 5. So now we have equation 4 and equation 5. Let's have them here. So negative 5y plus 3z is equal to 5. And then we have 39y minus 10z is equal to 206. And now For the second part, same idea. We're gonna pick a variable, we're gonna eliminate it, and just by inspecting the z variable might be easier to eliminate. So we can multiply the top one by 10 and the bottom one by 3. So 10 times negative 50 is gonna be 10 times negative 5 is gonna give us negative 50y. And then 10 times 3z is going to be plus 30z is equal 10 times 5, that's 50. And then 3 times 39, 3 is going to be 117. 117. Let me double check that. So I believe that's negative 39 because it was negative here. So it's negative 50 and then we have negative 117y. And then 3 times negative 10 is going to be negative 30z equal 3 times 206. 3 times 206 equal to 618. And we're going to add these two equations. So minus 50y minus 117 is going to result in 167 or negative 167 y, and then z and z are cancelled. 50 plus 618, that's going to equal to 50 plus 618, 668. So now we have negative 167y is equal to 668. We're going to divide both sides of the equation by negative 167. And then y is going to result 668 divided by 167. It's going to equal to negative 4. So now we found one of the values of the variables. We can go backwards in the equation to basically find z and x. So we can use, for example, equation 4 or equation 5. Remember, that's equation 4, that's equation 5. So I can use equation 4 to find what z is equal to. So I can have negative 5 times negative 4 plus 3z is equal to 5. So negative 5 times negative 4 gives us positive 20 plus 3z is equal to 5. We can subtract 20 both sides of the equation. So I have 3z is equal to negative 15. Divide both sides of the equation by 3. Z is going to equal to negative 5. So now I have y and z. I just need to find x. I can use either of these three equations to find what the x is equal to. So I have, for example, we can use the first one. So we have 2x minus 2, and then y is negative 4 plus 7 times z, which is negative 5, and that's equal to negative 33. So 2x minus, so 2 times negative 4, that's going to be negative 8, with a negative becomes positive 8, and then 7 times negative 5, negative 35 is equal to negative 33. So we have 2x. Now we can add these two. So 8 minus 35, that's going to equal to 8 minus 35. It's going to be negative 27 is equal to negative 33. So we're going to add 27 to both sides of the equation. So negative 33 plus 27 is going to equal to negative 6. So 2x is going to equal to negative 6. So now we divide both sides of the equation by 2. Negative 6 divided by 2, and then x is going to equal to negative 3. So now we have the solutions of x, y, and z, and that's equal to negative 3, negative 4, negative 5.